Hello everyone, welcome back to the session on Agentic AI. So, in the past couple of weeks, we studied right from what is LLM and what is an agent and what is RAG, correct, and so on. So, the last part of today is to discuss on Model Context Protocol (MCP). It's one of the famous protocol which is being used, correct, correspondingly. So, the session has two parts. First is introduction towards MCP, model context protocol, why we require that, and use cases, correct. So first we have to understand what problem does the MCP solves, correct. So when we used to connect to an LLM and we wanted to make use of tools, correct, especially when we want to integrate with third parties. Now, you will also agree with me that over a period of time, our agentic AI will land up creating a large number or integrating with a large number of services, correct? Integrating with large number of services. So, how to work with that services, correct? Is what we have to we learned, correct? We learned how to use @ tool with database service and API service. But over a period of time, when we have so many tools integrated, it will cause issues, correct? So how to fix that issue? The problem with MCP solves is MCP provides a uniform way of accessing data. Okay. So basically, how is the flow? LLM communicates via natural language or simple JSON, correct? External services communicate via specific binary HTTP or gRPC protocols, correct? So we have binary HTTP or gRPC protocols. So the custom adapter approach creates a massive overhead. As number of tool grows, the complexity of maintaining all these unique integration layers quickly becomes unimaginable, correct? So how can we fix this is the question. And the answer to that question is MCP, correct? So model context protocol provides a language agnostic standardized protocol which is designed typically for machine to machine communication. Yes, it can be used, it's predominantly used in agents and LLM, and we predominantly are using it with agentic AI frameworks, correct? So it has become one of the most adopted features as of today, correct? In the agentic AI world. So what you can imagine model context protocol, you can imagine it as a universal USB port. So any client can use it regardless of programming language they were built in. So universal port for all, correct? So the core functionalities are MCP standardized communication cycle. The tools are registered in a schema registry, tools discovery, correct? And based upon their inputs, corresponding tools will get discovered and called. Correct. The server executes the task and sends the structured result back to the agent. So it provides a uniform way of accessing. Correct. So how does NCP architecture look? So NCP architecture has two things. One is an MCP server. You can imagine this as a server which will expose a service, correct? Just like we expose a REST service, we can expose an MCP based service, correct? Now, one of the common implementations of MCP from Python perspective is fast MCP. Okay, so fast MCP can call it, and we can create servers, and we can use that servers with any fast MCP reliant client, correct, or MCP based client. Similarly, we also have MCP client. MCP client is available in different programming languages. Okay. One of the common ones which we use is with LangChain or Presence II. This all can directly talk with LLM, correct? So what happens is the agent's internal intent is converted to a JSON. So communication happens via a standardized JSON format, which is sent across network or local pipe, correct? It can be sent over a network, means it can use HTTP protocol. It can also send over a local pipe, means machine to machine communication. So NCP is carried, so the protocol, MCP is a protocol, correct? So that protocol handles various communication which can happen at the transport layer. And based upon that, it can either present the output in the standard IO object, like command prompt, correct? Or it can also provide by using WebSockets or TCP, used for communication across. So because of the adoption of this MCP, it creates a uniform way in which we can access, okay, all the services. So you can imagine MCP as a bridge. So they generally call MCP as a bridge between whom, between the agent and between all the third party calls. Okay. So what is the MCP impact? It becomes modularity. So tomorrow, if I want to change from one service to another service, it can be easily done. And while changing this, we don't have to change the agent's core code, correct? Core code need not be changed. Same way, it's multilingual. It can support various programming languages. So you can have client in other programming language as compared to the server, correct? And both of them can seamlessly work. It is scalable. It follows the scalable server architecture. We can scale it, increase it or decrease it based upon use. It provides security, correct? So agent can do many things like, uh, let's say you receive a file, instead of file being directly given to the end system, it can go via NCP, where additional levels of security can be wrapped. Okay. So all these different types of benefits you get by adopting MCP. Okay, so the first question comes, okay, we learned a lot about MCP. So how can we implement MCP? Correct? So the first example which we are going to do today is a simple MCP server. Okay, so this for MCP server, I am making use of a module with name MCP. You can install it. You can say pip install MCP. Now within MCP, there is a fast MCP sub package within which we have fast MCP server module. So I create the MCP service. I call it echo service. I have a simple echo function, correct? So what does this echo function do? It takes a standardized message and calls the message in uppercase. So I have annotated this with @mcp service.to. Now what happens is, as I told you, the biggest advantage of NCP is the protocol agrees upon a standard input and output format, a JSON-RPC format. Okay. So we get the request in the form of a JSON. I can show you that JSON if you want. It looks something like this. Are you able to see? So it will have a JSON-RPC version followed by ID, followed by method, followed by params. In params, you can specify anything like model, prompt, tools, tools import, whatever you want. Correct. So this is a standard payload which is agreed upon. So it has method, it has params. Same way here, as you can see, I am receiving that JSON and I am checking the methods and params. I am checking if method equals echo, call echo. So echo is a tool. So here it will go and do whatever processing it has to do. And then it will give the response in a standard format. You can see it will give the response in JSON-RPC. It will give the ID which came as input, and this is the result. Correct. Same way, there is list tools. Now in list tools, I'm just giving dummy data. Actually, this could also be called as a tool and corresponding returned as a message. But for now, I'm just returning the dummy data. And if a method comes other than this, it will not be implemented. It will give not implemented error. And then what I am doing is I am dumping this response back, correct? And say sys.sysout.flush. Now here I am starting, so I can run this single request in which this entire thing will work. Okay, so this is my simple server, and the script exists. After processing a request, it will go away, correct? In real world, we will have a server here which will keep on running, correct? Now I can have a simple MCP client. Again, this MCP client will again make use of subprocess. So subprocess is a module in Python. It's equivalent of command prompt or terminal, correct? It can open a terminal, it can open a command prompt. So what we are doing here, we are calling the MCP tool sync. So I am calling this server script. So p open, I am opening the file. I am giving Python command. So sys.executable is the Python command. The server script which we had, we put it here. Now in standard in, I am giving pipe. Standard out also I am getting pipe, and standard error also I am giving pipe. And text equals true, buffer size equals 1, correct? Now I am creating the sample request. So the sample request, you can see we have a JSON-RPC. I am creating a dummy UUID. In the method, I am passing the method which I am going to call and the parameters, correct? Then what I will do, I will JSON.dumps. So you know dumps creates a stringified version of this import, which I gave to proc.strin.write and flash. Same way, so after giving this, I am waiting for the response. And when the response comes, I'm waiting for 2. So you can see this wait method, it takes an argument, correct? Timeout. Okay, so it will wait for that much time. And then it will see if there is an error. If there is an error, it will print the error, correct? If not, it will stop the command prompt and print the response or return the response. So here what I am doing, if you see list tools equals call MCP tool, I am giving the name of the tool with a blank list tools, correct? Same way I am calling echo with this curly brackets, correct? With curly message. And whatever response it comes, I load that response and print the response, correct? Okay, so this is how I made a call to our service. So you see, this request format and the response format are predefined. Now, do you understand what advantage it is given? So all the logic of tool calling will be placed in MCP, correct? All the tools, any tools which we have, tomorrow we get a new tool, it will be integrated here. From the caller perspective, there is no difference other than just passing a new method to the call, correct? So see, it becomes so easy to extend. It becomes so modular. It becomes so clean that all the tool calling has to happen only from one place. Okay. So let's try running this. So if I copy this, I can go to that folder over here, CLS. So I'm inside this folder and I will run this simple MCP client. See, tools found. The result echo MCP success, final result MP success. You see, it made a corresponding call and printed the results. Everyone able to see that? So whatever echo we gave, that echoed. You're able to see it echoed. So this is how we can extend this. Everyone with me? So you can keep on calling it n number of times. Okay, so I repeat the code again. So What is the advantage of MCP? MCP is a protocol. So naturally it has standardized input and output discussed, correct? So what will be my input? What will be my output? That is very clearly designed. So in the import, we have JSON-RPC. JSON-RPC 2.0 ID, method and params. This is the input. And we also have the standardized output, correct? As I told you, standardized output again comes in JSON format, correct? If you see here, it comes standard JSON format with ID and result, correct? So when you call echo, echo will get called. When you call list tools will get called. So based upon that, the response comes. Okay. And here in the integration of the client, now client can be integrated in multiple ways. Here the simple example which we are doing is terminal, because we know this can pass the data in the form of pipe, correct? So we are calling it this way. Hopefully that makes sense, everyone. So we have the tool here which exposes itself, correct? So this is our first example which we did. Now in this example, what was lacking was the server was not continuously running. Only when the client we call, at that time server comes up, correct? So let's go and see the next example, correct? So the next example is very good server. So you see, I have this server. The server is emulating a third party, correct? So what it does is it uses Flask. Flask is used to expose a REST service. So in the REST service, whatever path I get, of that path, I list all the files in that directory, and we just give some details for the files. So a result I generate list of all the files and give the files by using JSONify. Same way I am doing tools.db.query, a post method, correct, in which we are getting the body in data.getSQL. So if select in SQL, I am just selecting these rows and sending these rows, correct? So it's a very simple server which actually connects to corresponding systems and gets the data from there. So when I start this will start a Flask server which will run on 9000 watt port. So why we created this server? This is not a MCP server. This is the server which is emulating the third party. Okay, it's emulating the third party service. Now, as I told you, we will create a bridge server. Okay, the aim of bridge server here is to provide ability to call any tools. So you see in the request, we are expecting the body to be of this type: JSON-RPC, ID, method, and params, correct? So we get the request object and from them generate the JSON, and we say body.get params, and then we say MCP invoke params. So MCP invoke params is a class where we are mapping our request parameters, correct? So model will become model, prompt will become prompt, tools input will become tools, correct? So whatever params we are getting, that params we are mapping here to MCP call. Now once we call this, we will get the model. If the model is not specified, then we will use the predefined model, llama 3. We will get the prompt, we will get the tools, we will get the tools input, correct? Now for each tool import which we have, as per the tools, we will check in the tool registry. So if you go and see tool registry, it's a simple dictionary with DB query and this. And if the tool inputs dot get tool name, then it will go and call this. And request dot post, we will give the endpoint, whichever endpoint is given. and endpoints are mapped to the tools. You can see, correct? Endpoints are mapped to the tools. So we are mapping it to the tools. We are giving the JSON input as expected by the tool, and we are waiting for the timeout. So whenever the results will come from there, I capture that result in the form of a JSON. Okay. Now what we are doing, after we get the request, we are making a prompt. In the prompt, we are saying, go to the model. This is how I require the response to be. And stream is false. And I call the generate with this payload, correct? With a timeout. And wait for this to succeed and give the response, correct? We can increase the time. 50 is quite less. We can say 300. So we are waiting here to get the response. So once the response comes from there, here in ID, we get the ID. In result, we give the tools result, the original result, and the Olama response. Correct? Both we give. Agreed? So you can see this is acting as a bridge. So from the agent perspective, agent will call only MCP. All the tools will be registered here. And which tools to call will be done by the MCP. Correct? So that's how this works. We start the server. Finally, we will have our usual client, correct? So this is our client. I am calling MCP 2.0. I'm saying invoke, make use of Llama 3. Prompt is this. Tools is file system dot list. So when I say file system dot list, if I go to the breach server, file system dot list is mapped here. You're able to see that. And tool inputs is file system path, whichever path you want. You can give dot or you can give the path of your choice, correct? So for example, I can say C colon slash slash R. So I'm giving this folder. Then whatever response comes from there, that response I am going to dump and show it on our screen. So see, this code of client will be actually the agent in real world. So agent will call there, and based upon the agent call to the intermediate bridge server will connect to any tools, and from that tools it will get the data. Correct? So that's how we are making this. So now our aim is to start each of the servers. Copy for. So we'll require 3 command prompts. Yes. Open. Let's go and run this. First, let me run the server. Server has started. Then we'll copy the path of bridge server. Then we can start the client. The path. I will say Python. Let's see what happens. So when I call the client, you will see a request would have come here. It already gave 200. You are able to see. So the request has actually hit there. Now processing is happening at the Olama side, correct? To format the data into required format. Okay, so response will start coming. See, response came. Are able to see all these folders which are present there is shown. So you see is directory true. Name of the subfolder is r.4.1. You're able to see that. Model response is this. Able to see? Everyone? So you see, so advantage. Now tomorrow, imagine that I want to integrate this with one more tool. Okay, so let me stop this. Imagine that I want to use this with JSON placeholder, correct? JSON placeholder tools. So what I will do, I will go to the code in the bridge server. I will register this. So we will say to-dos list colon and give the URL of to-dos. Okay. Now when it comes, of course, this all will not change. This all will remain same. It is use post. Now whether we have to use post or not, now that we can also determine from the params. Okay, now here what we have done is we have directly use post. But in real world it can also be non-post, correct? So import equals post. So let's do one thing. Let's use that params. So if params dot get HTTP method double equals to get r equals request dot get endpoint. Else or dot this then raise. Raise it and then take it. This is how we will use. That's it. So new tool is registered. So now if I have to use it, the only thing I will have to change is the client. So I will create one more client, copy, paste it, and I will say client one. Okay, so invoke you can see count how many to-dos are present, give first and last. Okay, the tool's name, which we are going to give here, to-dos list. To-dos list. And I also created a HTTP method, correct? HTTP underscore method colon get. So this will call get. So now I save this. So now let's run this client one. So copy path, come back here, say Python Sorry, I stopped the server, so I will have to restart this. Yes, this restarted. Here, let's see whether the request came here. Oh, I made it wrong. This should have been HTTP method. You just go and stop that. Didn't I change? Tools name change, huh? No? Became wrong. Give me 1 sec. Accidentally, this should be HTTP method. And this should be mapped to to-dos list. Tool import is no importance here. We can pass an empty array. Let's open this. New CMD Python part. Now I think it should be a good request. See? Request came. It will process the request. Should get the data from tools. You have to wait for a couple of minutes to get the response. So once the response comes, we will be able to see. So you see, integration with any tool is directly straightforward. Let's wait for the response. So integration of any tool just requires adding it in the bridge server, correct? So as soon as I add it in the bridge server, everything will become available. In the meantime, when it's running, let's also see what Alama is doing. It didn't get generated correctly. You have to stop and start again because it's not working correctly. CMD, CMD. It's open again. I think there was some formatting issue. Let's also put some notes here, correct? Print tools results. Format. Tool. Okay, just to see. Okay, so let's go and run this. Python. Copy the pitch server. Path. Net. Same way. I will copy client one from here. See? Let's see what response comes. See, response got printed. So that means now it's going towards Llama. I've also restarted Llama. So now response will come after some time. Because this printed the results, you can see. That means it was able to fetch. Now it's given the request to our LLM. So let's wait and see what it gives. This is the way the MCP acts as a central place for all tools registration. Correct? So the only place which will change is the MCP. Agents will not change. Just taking time because of the LLM. Once the LLM gives the data, then it will go to the. So similarly, adding any tools will just require changes here. Hopefully that makes sense. And the request maker is how in a standard payload format, correct? Because of making this, it becomes straightforward. Now, what we are going to do now, how to use it in agentic AI framework world, correct? So So in the agentic AI framework world, we will make the agents agent.run, and in the tools, just like we had this file system tool, we will just post it there. Correct? In fact, we don't have to do this much also. Whatever request we get, we always have to go for MCP. We will just feed MCP with the JSON format. So once we do that, all the tools will work there. Correct? So request to that particular tool will go there, and from there we will be able to get the response. So we'll show an integration with that also once this finish. Second time maybe we start on. So let's create our agent. Copy and paste the agent which we made yesterday. Let's change it. So let's say agent with bridge. Agent with bridge. So these are our tools base. Okay, so if I go to the bridge server, bridge server works in 80. So we'll make a request. So we will do two things. We will get all the tools which we want from tool base. Here we are getting it from 9001. We should not access 9001 directly. We get everything from MCP, correct? So we create the JSON format like what we made here. We call So we will go to the agent bridge. Now here instead of calling this, come here. Okay, so path is this. This path we can pass as an argument. Same way. In fact, we can make a simple method here, call MCP. So we can go down and say def call MCP. And in call MCP, I just have to pass the payload. Payload, and in the curly bracket, just call this. Here, which URL is here. This all can come from environment. For now, I'm just keeping it there. And payload also can keep there. Okay, for now I keep it here, payload, and just say return call MCP. Now bracket you payload. This can also be made proper, but for now I just use this. Same way, also call the same thing. So it will not be required. DB query. DB query will also call the same server with payload. So here in DB query, this I will remove. And instead of this, what was our mapping in the bridge server? So in the bridge server, the mapping was DB query. What we did in DB query in the server. The SQL we will have to give select. Correct. Go back there. Tools as per bridges, DB query. Prompt is, we can say, summarize the results. Summarize the result in single line. Okay, and DB query, and the tool imports is select. So where is the tool inputs coming in the bridge server? So if I go, yeah, tool inputs come separately. So if I go to client, tool inputs, let's copy that, go back to our agent bridge, tool inputs, DB query, SQL equals select. Okay, give this, call MCP, this will go away, come back here, this will go away. So DB query, just call this correct initialization. Okay, I think this should work. But here Llama 3 is already there. So here in the MCP call, which we made in the bridge, it's doing both. So here from the agent perspective, it will not require LLM. It will just require plain data. So the original code was correct. It was just getting the plain data from there. But that code has to come from MCP. Okay, so MCP will do both. So we will just have to modify our MCP to just return the data, correct, in JSON format. That's it, rather than applying LLM. Okay, so we will create one service for that, and then this we can modify. In meantime, what happened here? Okay, so I think our Olama server is down. So we have to restart it. Just give us 1 second, because it has a lot of requests. Else should not come from there. Run this. Rerun this. Hopefully now it comes proper. Go back, see the logs, and then hit it. Straightforward. Now it's better. Now this will run. Okay, in meantime, we will change the agent bridge to just return the results, correct? And give it to, so in the current implementation, we are doing both. But in the bridge server, we will create one more post mapping. It does the same thing, but without having to call. So say MCP1, just name that as MCP1, MCP entry 1, everything else remains same. But instead of going towards the prompt, tool registry call happened. We got the request, we got the response, and this response I will pass back. So return and give tool results. Olama response is not given. And that tool results will be then used by the agent to give to Olama. Correct? So whatever result comes, that result will be given. Yes, go here in the agent's bridge. So this will just call, actually this should call only one with the corresponding details. For now, we have created two just for the sake of simplicity. And when this tool runs, whatever results comes, that result we will use. Okay, so once I run this agent, it will get the data from MCP. We'll have to restart the server again. So we'll just wait for this output to come fully. Give the response. I think the data was quite big. We could have given a smaller data maybe. That would have made it more interesting. So data is quite big. It's taken time. Actually, it should not take this much time, but because it's running on my local, that's why it's given this much time. So what we can do is, let's say to-dos one. Let's start the server. Otherwise, it will take a lot of time for both the agent and this to respond. So just say to-dos one. In the client one, we will just give a simple question. Summarize result. We'll do this and run the server. This is just to save time. Otherwise, the original code will also work. Okay, server is up. Go back. To our bridge server. CMD. Python. Bridge. Go back again to Agentic. Let's see what it gives. Okay, this is a single list. I think this should be relatively faster. Something is crashing at the server level in Olama. Other than that, everything else seems fine. Okay. So this is how this works, guys. Now, from agentic bridge perspective, again, I can run this, but again, it will go to Llama 3 only. So some way the Olama in my machine is crashing. So we may have to reinstall, which will take a lot of time. But other than that, the concept of MCP is clear, correct? So we have a centralized location where all the tools will be registered. We can expose a service which will list down all the servers. We will call this service to correspondingly call the tools with our bodies. And that will be then passed on to the server. If required, it can be massaged here itself. But if you are using agentic AI, you can massage it separately by using LLM because we can have multi-agent handover and all, correct, which we discussed. So we can just get the response from this particular server and based upon that, we can use it, correct? So that's what is the use of MCP. So while this runs, let me just recap once again. So the problem which we are trying to solve from MCP perspective is that without MCP, if you try to integrate the tools by using @tool mechanism, which we learned many days before, it will land up making the agent very much clumsy, correct? It will make it very much clumsy. So to avoid that problem, we create a centralized MCP server where all the tools and interactions with the tools are registered, correct? Now, how to talk to MCP? So MCP also has a protocol. To talk to MCP, the protocol of input request is already defined, correct? We have a JSON with the structure uh, as shown here with the methods, correct? and params and models and prompt and tools input, correct? Same way, the response is also predefined with JSON and response. So based upon this input and output, we will be able to use the corresponding, pass the corresponding results and present in a uniform way. So that's the major use of MCP, to present the results in a uniform way, correct? So the result is working. Only problem is Olama today is slow on my machine. If it works faster, it would have given the results faster, but there is some issue and installing it completely will take a lot of time, correct? So, so this is how this is working. So that's MCP for you. So since today is the last session, let me recap all the things what we learned till now, correct? So first day we started with what is LLM, what is the role of LLM, how LLM works, what is embedding, which is vectorization basically, correct? Then we went and learned how LLM and agents differ, correct? So what can agents do further as compared to LLM? Then we also learned that agents can also bring data by using tools, correct? From by using API or database. That makes agents more intelligent as compared to LLM. Then we learned that we can also have multi-agents, correct? Like agent number 1 talking to agent number 2, talking to agent number 3, with each agent being specialized in specific task, correct? So there can be handover from one agent to other agent. Everyone with me? Everyone with me? And agent 3, and then we further went and learned about how to use LangChain. Then we also used True AI, correct? Then we learned how to connect to database, how to connect to external API. Then we went and learned about RAG model, correct, which can retrieve data from particular sources based upon the request. It can bring data from PDF, documents, and so on. And then we extended this example further to Streamlight, which provides a UI which can fit very easily with the agentic AI world, correct? And then further today we extended this. We also learned about custom workflow. How can we create our own workflow? Correct. We also learned how can we restrict the scope of agentic AI to answer specific questions only, correct? And today we also went ahead and learned about MCP, correct? What MCP performs, what roles it performs, and so on. So this is what the entire agentic AI is. We also did a lot of examples. As you can see, our complete exercise was, our complete sessions were all driven by more examples, each of which is committed in the GitHub, correct? We also learned about how to use FAISS and also how to deal with ChromaDB yesterday, correct? So this completes all the working of agentic AI. So today is the last session, as you know. So we have opened a command box in which you can put your comments and drop us in email how you felt the sessions are. We covered a lot of topics within very short time, giving you the brief of how AI is evolving and how it will impact each of us in future. So request all of you to share the feedback, as it will help us to improve and take this to next level. And hope you all enjoyed this session together with me, correct? So you can share your thoughts with us, and give me one sec. In the comments, you can see this. Write your queries. This is our corresponding email ID. So feel free to contact us for anything, any doubts, any questions, and hopefully you all enjoyed this session and hope to see you in near future, correct? And also please subscribe to our channel, and as you know, we keep on giving you new topics and we try to get you the latest cutting technologies, correct, which no one easily dares to approach. So thank you very much for your time. Hopefully you all enjoyed this session and wishing you all the best with Agentic AI. Thank you.